Okay, if you have not watched the other video, go ahead and pause this one now and watch that. Now, our first problem is a piece of ribbon is Y centimeters long. Ashley cut it into 4 equal pieces to do her 4 sisters' hair. Write an equation for the amount of ribbon used for each sister. This one's simple enough, but we're still going to use the T-chart the man used originally. We have know and don't know. Okay, so what we know is she's cutting it into 4 pieces. What we don't know is how long the ribbon is. They went ahead and gave us a variable of Y, so Y is going to equal the centimeters long. And now we're ready to write our equation, because this is all we know and this is all we don't know. So this one's simple enough. She's cutting it into 4 equal pieces. Whenever you're dividing something into 4 equal pieces, what operation are you going to use? You're going to use division. So Y, which is how many centimeters long our ribbon is, because we don't know that length, is going to be divided by 4. So Y over 4. And that's it. That's all we need to do. So let's go ahead and plug a number in to show you how this works. Say the ribbon was 12 centimeters long. We would replace this Y with 12. So that would be 12 over 4. And that would equal 3 centimeters. Easy enough, right? So here we go. We'll go ahead and move on to the second problem. Our second problem that we have is Margaret has 16 yards of fabric and she is making dresses for Z dolls. Write the expression for the length of fabric used for each doll. So what I would like y'all to do is to go ahead and figure out what we're going to do for this one. Alright, so she had 16 yards of fabric, and so we're going to put that in the known. And the unknown, or don't know, is how many dolls is she making dresses for? Number of dolls. And they want us to use Z as our variable. So Z equals the number of dolls. Now this one's going to work a lot like the last one we did, except for this time we actually know how much fabric we have, and it's 16 yards. And the unknown is how many dolls there's going to be. So our unknown is going to go on the bottom. And the way that would work is if, say, there are 4 dolls, we would replace Z with 4 and then divide. So 4 goes into 16 how many times? That's right, 4. Okay. Third problem. Olivia has 14 needles in her sewing kit, but she lost R needles. Write an expression for the number of needles in her sewing kit. So go ahead and make your known and unknown tables, and then come up with the expression, and I'll check it to see if it's right. So with this problem right here, Olivia are what we know, what we don't know. The know is 14 needles. What we don't know is how many lost. Okay? And it says we're going to use the variable of R to represent how many are lost. So when you lose something, what is happening? It's going away or subtracting. So we're going to start off with our 14 because that's how many she had, and then we're going to subtract from it how many she lost. How many did she lose? We have no idea. We're using R because that's a variable. It could be anywhere between 0 to 14, and that's that expression. Go on to our fourth expression now, or our fourth problem. After money X of a discount, Emma paid $159 for her new sewing machine. Write an expression for the original price of the sewing machine. So we'll go ahead and pause this. I want you guys to take a stab at this one also. Alright, so this problem right here, I know and don't know. We know how much she paid for the machine. She paid $159. But she got a discount. How much was the discount? No clue. So our discount, we're going to make X and we need to know how much the sewing machine originally was. So when something is discounted, that's a subtraction. Is that correct? Alright, so normally what you would think is you would subtract X from $159. But if you did that, you need to look at the problem a little bit harder. After the discount, she paid $159. So we want to know the original price. So what is the opposite of subtraction? It's addition. So $159 is the discounted price. That's what she paid after money got taken away. But we want to know how much the original price is. So what we're going to do is we're going to add X. And that will give us the original price. So just to show, say there was a discount of $10. We'll replace the X with 10, and the original price is $169. That one was a little bit trickier. So that's one reason you need to read these problems, read them over a second time, and see what they're asking. They're not always going to be cut and dry like the first problem or two that we did. Problems like number 4 are set there to trip you up. Pay attention, guys, because the stuff gets harder and harder. Alright? So just make sure you're double checking your answers. We're going to do one more. In Charlotte's sewing kit, there are T bundles of thread. Each bundle has 34 feet of thread. Write the expression for the total length of the thread in her sewing kit. So we'll go ahead and pause this and let you figure that out. Okay, so here again, what is known, what is unknown, or we don't know. What we don't know is at the very beginning is the bundles of thread. How much thread? What we do know is that each bundle is 34 feet. So we need to write an expression for the total length of the thread in her sewing kit. So if each one is 34 feet, say she had 2 bundles of thread. The first one's 34 feet, the second one is 34 feet. 34 plus 34 is 68. If we had 3 bundles, 34 plus 34 plus 34 is 102. Or multiplication. So what our answer is going to be is T for the bundles of thread, and then it's being multiplied by 34. Or you could have also written it T times 34. Either one of these numbers will work, because it's 34 times the number of bundles of thread that you have. Alright, if you didn't understand these questions, or if you missed a couple of them, I encourage you to go over this particular lesson again. You can take it again, get a better grade. If you did well in it, or you're satisfied with how you did, go ahead to the next lesson. And I'll see y'all later.